Alright, welcome to the lesson about completing the square and also square root method. Now on these warm-up problems, these are representing perfect squares. A perfect square is when any expression is being squared. This is a binomial being squared. It's got two terms in it. So if I were told to simplify that perfect square, I would multiply x minus 3 to itself because it is being squared, and then start distributing. So x times x is x squared, x times negative 3, negative 3x, negative 3 times x minus 3x, negative 3 times negative 3 is positive 9. Then I'd combine my like terms in the middle, so x squared minus 6x plus 9. That's my simplified version of this perfect square. Now this is also a perfect square. It doesn't look like this one. We'd have to factor it to see it as a perfect square. So if I'm factoring this one, 16, and I write down the numbers that multiply to 16, I would say that 4 and 4 is what would add to 8. So I'm going to use that right there. So x squared plus 4x plus 4x plus 16. And that would be x times x plus 4 on my first group. And here my GCF is 4. When I factor that out, it's x plus 4. So it's x plus 4 times x plus 4, which would be x plus 4 squared. So perfect squares always factor to an expression being squared is what makes them a perfect square. Alright, we're going to be using this on the coming lesson. First, though, I need to talk about using square root method. Now, that's something that you can only do this when there's no bx term. So use square root method when there's no bx term. Alright, now how to do this would be to actually, you don't want it equal to 0, you'll just solve it as you would have traditionally, as if it weren't squared. So first I will add the 25 over, and then I will divide by 5. And this was x squared. Now my last step is different. What I need to do is I need to plus or minus the square root. The reason for the positive or negative is because either if a negative value was squared, it would still equal positive 5. And if a positive value is squared, it equals positive 5. So that's the reason why it can be either of these. This is saying positive square root 5 or negative square root 5. So there are two distinct answers here. That's actually my final answer. If I try to simplify the square root of 5, I cannot, because there's no perfect square that will divide out of it. One last mention on this problem, that's actually an answer that would be unattainable with a calculator. Neither the Desmos nor the Texas Instruments is going to get you that answer. Alright, at the top is your forms for your perfect square trinomials. That's helpful. That's actually what we were seeing on the warm-up. This over here is simplified, this over here is factored, whether there's subtraction or addition going on. Alright, now let's go ahead and take a look at how to solve this by completing the square. In this case, when you're solving by completing the square, you only want your ax squared plus bx on one side. Also, you want your ax squared to be positive, like it is currently. So this is actually set up for completing the square. Now what I'm going to do is I am going to add a value to both sides, and that value is going to come from the formula b divided by 2 squared. B is negative 6 on this problem. So I'm going to do negative 6 divided by 2, then I will square it to know what to add to both sides. Negative 6 divided by 2 is negative 3. Negative 3 squared is positive 9. You will always be adding a value to both sides. You will never be subtracting a value from both sides. So I'm going to add 9, add 9. Now I'm ready to go forward with completing the square. This left side is x squared minus 6x plus 9, which is now following this form, and it equals 256. Now what makes this useful is now we can write this as a factored perfect square. It will factor to x minus 3 squared. Now, how I know that is because it's always going to be what b over 2 was before I squared it. So since it was negative 3 before I squared it, that's how it factors. That's because negative 3 times negative 3 would be positive 9, and negative 3 plus negative 3 would be the negative 6x in the middle. And it equals the 256. Now this is where example 1 comes into play. I'm now ready to use the square root method. So x minus 3 will equal the positive or negative square root of 256. Now, unlike example 1, this is actually going to be rational. There's no magic way I know that. It's just that when I grab my calculator and I go square root 256, it actually gave me 16. So I'll use that value. X minus 3 equals positive or negative 16. Now, in this situation, to wrap this up, what I'm going to do is I'm actually going to split that up into two equations. X minus 3 might equal positive 16, or x minus 3 might equal negative 16. Either way, I've got to add 3 to both sides, so here x would equal 19, or when I add 3 on this one, x will equal negative 13. There's my two answers. These answers could have been gotten by the Desmos calculator, so that's actually still a good place to start. Even though it said solve by completing the square, you could have gotten these answers from the calculator. Now, we're going to be seeing other situations where that's not going to work out. Alright, on this next example, I went ahead and graphed the expression that was equal to 0, and I'm seeing two answers that are actually rounded off answers. These are not exact answers, which is the expectation now that you're in Math 2. So I'm actually going to go ahead and solve this thing using completing the square to get some exact answers. So let's go and see how that works. First thing, I'm going to subtract over the 32. The reason for that is I want to be able to complete this square over here on the left without its interference with that. Now I left a little space here on purpose. That's because that's where I'm going to complete the square, hence the name of the operation. To complete the square, that's where you use the formula b divided by 2 squared that I gave you a moment ago. And b in this case is negative 20. Negative 20 divided by 2 is negative 10. Negative 10 squared is positive 100. That's what I'm going to add to both sides of the equation. Now that I've done that, I've actually have a perfect square trinomial, and it's following the form a squared minus 2ab plus b squared. So what I'm going to do is I'm going to factor that to a, which is x, minus b squared. Now again, you're always going to see that be the b over 2 before you squared it. Negative 32 plus 100 is 68. And now I'm ready to use square root method. So here's square root method. To get the square away, I'm actually going to have the positive or negative square root of 68 on the right hand side. That's the biggest step there. Now I have to simplify the square root of 68. Now I've already figured out that 68 could be divided by 4. That's the only perfect square that actually goes into it. It goes into it 17 times. Now what I'm going to do is I'm going to square root the 4, which will be 2. 2 root 17 is what x minus 10 is equal to. One last step and we're going to be done. We're going to add 10 to both sides. So x is equal to positive 10 plus or minus 2 times the square root of 17. 10 plus or minus 2 times the square root of 17. You could write this out separately if you want to. You don't have to write this down. But your two answers would be 2 plus 2 root 17 and 10 minus 2 root 17. Now that's actually equal to the approximate answers that we saw on the Desmos calculator. Just one last thing I wanted to show there on that. So if I were to actually type in 10 plus 2 square root 17, that would be 18.2, and that lines up with what I saw on the Desmos calculator. That checks out. If I do 10 minus 2 square root 17, 1.75, 1.75, everything's looking good here. So you can use the calculators to kind of like check your answers at the end here. But here's my two final answers. By the way, these are called irrational answers. Just like example 1 was irrational because of square root 5. Example 2, however, those were rational answers, and that's the reason why we could have found those using the calculator. Alright, this is my last example that I'm doing with completing the square. What's going to happen here is I'm going to go ahead and subtract the 16 over so I can make space to complete the square. So I'm going to have x squared minus 14x, leave a little space here, equals negative 16. In that little space, I'm going to complete my square by doing b over 2 squared. You know what value that needs to be. B here is negative 14. And that's going to be negative 7, which is squared to give you positive 49. Plus 49, plus 49. Alright, now I'm ready to, this is pretty easy over here to add together. That's going to be positive 33 when I do negative 16 plus 49. This over here I'm going to write in its factored form, which is going to be x minus 7 squared. If ever this value is positive, that would be positive. And now I'm going to have plus or minus the square root. Now, 33 is not going to be able to be simplified, and the reason for that is none of my perfect squares will divide in to 33. So 4 won't, 9 will not, 16 nor will 25. So since it will not have a perfect square divided into it, I'm going to leave it as such. All I need to do here is just add the 7 over to be finished. So x will equal positive 7 plus or minus the square root of 33. And that's finished. Now in this last one, we are going to be experiencing a fraction, and that's actually all right to deal with. It's actually all the same work. So subtract the 3 over, so x squared plus 5x, leave a little space, equals negative 3. What I'm going to do now is the b over 2 squared part, which is going to be 5 as my b value, divided by 2 squared. I cannot divide 5 by 2, and that's actually simplified, so I'm just going to go ahead and square both those. So 25 over 4 is what I'm actually going to be adding to both sides. Plus 25 over 4, plus 25 over 4. Have to do it to both sides, or else you've messed up the problem. Alright, now I'm going to go ahead and add the negative 3 with the 25 over 4. Just going to use my calculator for that. And I'm going to convert that to a fraction, 13/4. So positive 13/4. Now on the left side, you might think that this is a disaster to try to factor. Actually, it's really easy if you remember what I say. I have x, and it will be plus, because it's positive, plus 5/2 squared. And the reason for that is if I square 5/2, I would have the 25/4. 5/2 plus 5/2 would make 5 in the middle. So that's actually pretty easy if you just remember it's always the value right before you squared it. Alright, now I'm 2 steps away from being finished here. Really 3, I guess. So I'm going to go ahead and plus or minus the square root of 13/4 since it was squared. That got rid of the square. Next, I'm going to simplify this. I cannot square root 13, nor can I simplify it at all, but I can square root the 4 that's on the denominator. So here's how I'm going to write that. I'm going to have the square root of 13 on the numerator, and 2 is on the denominator. And I have x plus 5/2 still. I have one final step, and that is to subtract 5/2 from both sides. So x equals negative 5 halves plus or minus the square root of 13 over 2. Now this is actually my two correct answers. One of them is where I'm adding, one of them is where I'm subtracting in the middle there. But as a nice little touch here, you could actually write that as a single fraction, since it has a like denominator, it's really easy. It'll be over 2. And the numerator would be the negative 5 plus or minus square root 13, and you'd be done. That represents both answers. All right, that's completing the square. Very tough process to learn and to master, but that's going to be what you're expected to do. Thank you for watching.